Right, so the first topic in AS chemistry is thermochemistry. So thermochemistry kind of brings us back to last year in terms of exothermic and endothermic reactions. That's kind of the first thing that we're going to look at. So exothermic, something that gives off heat, so heat exits, and then you've got endothermic with heat entering. You've then got your reactants, your products. That bit there, okay, is your activation energy, and then the bit between the reactants and the products is the energy released if it's exothermic. But then it's energy, so it's between there and there, so products, reactants is energy like taken in if it's endothermic, because energy is entered, okay. Enthalpy changes, so if they're formation or just a reaction one, okay, it's the wrong way around from what you were taught A level, so it's products minus reactants, okay. Very rarely it asks you to do that, but just in case. But if it's a combustion one, it's reactants minus products is what you normally use. So enthalpy on its own can't be measured, okay, it's like the energy of a reaction, so what we measure is enthalpy changes, the change in that's taken place, okay. Most times in a laboratory, not always in a school laboratory, but in a normal laboratory, they happen under standard conditions, okay, and you need to know the standard conditions off by heart. They might ask you, okay, and sometimes then the reason the experiment doesn't give the exact results, the results that you'd see in a experiment, is because it's not under standard conditions. So moving on then, so how do we normally measure enthalpy changes? Enthalpy changes tend to be measured using calorimetry. There's basic calorimeters, or there's like the bomb calorimeters, which are more accurate. The bomb calorimeters tend to have stirrers to keep the temperature constant, like a constant flow of oxygen to make sure it combusts properly. They're properly insulated. So that's like a very expensive one. The ones that we've used in school are called just basic calorimeters. Polystyrene cup with a lid, thermometer. You put your reaction in here, okay. I think we did magnesium and acid. Put it in there, and then you measure the temperature change over time. We plot that in a graph. They often ask you to measure the temperature of the acid before you add anything, so you get like a baseline, and then that's where it levels off, and then you'll be able to extrapolate the data. So we're looking at normally between that point and that point, so we can kind of like extrapolate that data there and get a good reading. So moving on then, over to bond energies, okay. Bond energies again is something that you did last year. Ooh, the whole thing's moving. Did last year. So bond energies is described as the average value, okay. Average values, the energy, and this is the definition, you need to learn the definition. The energy required to break 1 mole of the stated bond in a gaseous state under standard conditions, okay. Bond energy is only approximation, remember that, as the average bond energy will be the average bond energy enthalpy for a different range of compounds. So say I've got a CO bond. That CO bond could be in, if I do it like that, that could be in an aldehyde, that could be in a ketone, because we don't really know what's going on, could be in a carboxylic acid, just basic ones now. Now, all of them are slightly different compounds, but that's the same bond, so it'll be given an average bond energy, okay? To find the average bond energy, the sum of the bond enthalpies broken, so reactants, by the bond energies made, which is the product, and it'll tell you whether it's exothermic or endothermic. This is GCSE, remember, positive exo plus endo, okay. It will ask you to work out bond energies, and the confusion sometimes comes with people thinking they need to use the enthalpy changes, but they'll tell you to work out bond energies, so that's how you know how to use it. Finally, for thermochemistry, so the last thing that we studied is a lie. It's not the last thing we study. So the next to last thing then is Hess's law. So Hess's law states that the enthalpy change of the reaction is independent of the route taken. So it's independent of the route taken, and you need to know the definitions for the enthalpy change of formation and the enthalpy change of combustion. Okay, so they're two different reactions that you need to know. It's quite easy. Enthalpy change is when 1 mole of substance is produced from its elements under standard conditions. Okay, it's always under standard conditions. It's always 1 mole. It's always an enthalpy change. You just need to remember which way round they are. Okay, you might be asked to define Hess's law. So I've just written root 1 equals root 2. The enthalpy change is independent of the route taken. Okay, so if we look at formation, with formation, arrows always go up. Arrows always go up. And then we're looking at, that would be root 1, the most obvious way there. That'd be root 1, but then obviously we could go that way. Okay, that would be root 2. With these would both be 0 because any elements are always 0. The enthalpy change when they form is always 0. Okay, they can ask you loads of different things. Okay, they might ask you to work out that value there, or they might give you that value and ask you to work out here. Okay, it's all about knowing that whatever's going that way, R1 equals R2. Okay, remember, other thing you need to remember is if you're going that way, then this arrow and this arrow are the wrong way round. So if these were actually elements that had, not elements, if these were compounds that had values, you'd have to swap around their signs. Okay, then moving on to combustion. Combustion arrows always go down. Okay, it's the same kind of thing. Again, root 1 equals root 2. So say I had 100 for that, 100 for that, 50 for that, and 50 for that. Okay, a couple of things that would need to be done. Okay, there's a 2 there, so that would have to be times by 2, 3 there, times by 3, 3.5, so times by 3.5. Worth working out them values first. Okay, imagine they're all positive values. If we're looking at arrows, that would be the wrong way around, so have to change that to a negative, and that would be the wrong way around, so have to change it to a negative. Okay, so then all them values then, so 100 plus, what's that, 350, plus minus 100 plus minus 150, that would all equal the root 2, and then the other one would equal root 1, so we could use that then to work out root 1. But it might have to rearrange. It might ask you to work out this one here, so you'd have to like input it into the equation and work it out. And then finally, the last kind of thing they might ask you to do is to use this equation. You won't be given the equation, okay? You have to work it out. And it's called measuring enthalpy changes, okay? Obviously, that means the difference in the temperature. Mass is the mass of the solution, so whatever is in solution in aqueous form, and then C is a constant value. It's the specific heat capacity of water. They normally give it to you, but if they don't, it's 4.18. Okay, if they then ask you to work out the enthalpy change per mole, you need to divide it by the number of moles. It could be 2 ways of working out moles. Okay, it might be concentration times volume, or it might be okay, so there's 2 different ways depending on what you've got. It's not always a very accurate way because it is measuring it relies mainly on the temperature change, and there might be heat loss, okay, due to convection or conduction. It might not be insulated properly, etc. Okay, that's just a brief overview. Obviously use all your other notes, but that just might help some people get started on their revision, maybe something they're stuck on, or you could use it and tell me in class which ones you still don't understand.